Okay, so for those of you who are interested, this is my 6-foot dish. It's an Anders dish mounted on a quick-set tilt pan head. So this quick-set tilt pan head is one of the versions that is a DC version that has speed control on the motors, and it has either pots or resolver feedback. This one has pots. Resolvers would have been nicer, but you know, they're a little hard to come by these days since they're fairly old. The actual control unit that you see up here, this box now is the new radio for me. So basically what I did was design or fill in a box here. It's an old MACOM white box that has the RF and a control system. So get the glare off the screen here. What you're seeing up there is a little 7-inch touch panel display that's displaying the current absolute readout. There's a Windows 10 based embedded computing system that's monitoring the TWT. You can see the TWT is on. I can remotely control the TWT, the push to talk, can monitor the currents, the temperatures, even the RF output is calculated here. And all of it is sent, you can see the Kune transverter in there. All of this is sent back to the host, which is a laptop that can be in my truck, can be in my home. All of it is sent back to the host over a coaxial cable, and in this case an Ethernet cable, although wireless is doable as well. There's a wireless interface on the Windows 10 computer. My plan is to combine the DC, the IF, and the Ethernet, the 2.4 gig Ethernet all into the same cable there, so that I only have one cable going up here. The other cable you see here is power and quick-set head control. So all of this is mounted on a tripod and then onto a pallet that fits in the back of my truck. So now I do need a little shorter piece of waveguide here. You can see that looks a little messy, but that's how I get the output. There's quick couplings on the actual waveguides. They can be just flip a switch and they're off. No screws to remove. The dish itself, you can see, is rather large. If I come back around, I've got a 4-foot dish that fits on here as well, which is a little more convenient for transport. If I come around here right now, what you can see here, I'm remotely just set up on the table right now, but I have both the SDR software for SDR Play in the background here, but the app that's on top of the desktop here is actually one that I've written that allows me to display the heading. And you can see right now I've got it set at a heading of about 90 degrees and my tilt angle is 2.6 degrees. Using the joystick or what I've got a later release of the software now that I'm setting up to just enter the grid square. But using the joystick, I can move the dish around, move it backwards, move it down, can move it up. That's at half speed. I can also slow it way down. That was basically a fairly fast pan. I can slow it down to virtually a crawl, but you really wouldn't see it on the movement here. But it's possible to reposition this antenna basically to within about 1 to 2/10 of a degree, get it back on a new heading. So this is kind of nice for me because I haven't really finished the radio end yet in the laptop, but the radio and the laptop can fit inside of a truck or set on a table underneath one of the pop-ups, easy-ups. This was rather nice because you know, in the August contest in Arizona, it's pretty frequent to have temperatures of 100, 110 or more, and we also get some thunderstorms in the afternoons and things like that. So basically, the rig sets in the back of the truck and is all sealed up. Don't care if it rains. I can set in the truck, listen to the radio, so I'm not fighting wind noise. I can also listen to or adjust the dish to wherever I want. I can see signals on the